Okay, cool. Now that's recording, and I just stared at it for a minute. All right, so I want to do 2.6 over 15, which says I should try to solve this by finding an integrating factor. And this I'm trying to solve is 2xy plus y squared dx plus 2xy plus x squared minus 2x squared y squared minus 2xy cubed dy. Okay, so first things first, what should you try before you spend any time trying to find an integrating factor? Yeah, check if it's exact right now. How do I check if it's exact right now?
Curl test.
The what?
Curl test.
The curl test. Yeah, for sure. Apply the curl test. Right? So take this thing. What do I take this thing with? Okay, so take the partial with respect to y. So I'm taking 2xy plus y squared, partial with respect to y. Oops, those are the wrong d's for this. Partial with respect to y. Get 2x plus 2y. Okay, then take the partial with respect to x of the other one. 2xy plus x squared minus 2x squared y squared minus 2xy cubed. Okay? Oops, I don't know why I put parentheses in there. What does this give you?
2y plus 2x.
2y plus 2x minus
4xy squared.
4xy squared minus 2y cubed. Okay, cool. Problems?
Yeah.
Yeah, those are not the same. So, as it stands, this is not exact. Okay, so what do you check to see if you can do better?
If you can find an integrating factor.
Yeah, so what do you check to see if you can find an integrating factor?
You could start with mx minus my over, or sorry, my minus nx over n. What you've done there is
So
subtract
this minus that over
and the second one.
one or the other of these, right? Okay, so I would recommend that you, I don't know, pick one. Like start with something. So usually this is n and m, m and n,
M and n.
m and n. Dude, look, it's been that kind of day. So I'm going to start with my minus nx over n. Okay, so that should be 2x plus 2y minus all this jazz.
Want to start with the easier one first? Yeah. Just about.
What easier one?
Yeah,
Oh,
so
where the
you
bottom's
You
easier.
seriously want to divide by n.
Okay, well I'm not erasing that, so let's try the other one. That's nx minus my over m.
Yeah.
Okay, so let's start with that one. Fine. Whatever. So take your 2y plus 2x minus 4xy squared minus 2y cubed. And do what with it? Subtract the other thing first. So slash a minus 2x and a minus 2y. And then divide by
2xy plus y squared.
m. 2xy plus y squared. Okay, so cross the out sees some stuff. Cool. Notice that what you have there, you can factor what out of? Yeah, you can pull it. You want to pull a negative 2y?
Yeah, I want to pull negative 2y out of the top.
Okay, so then you're left with 2xy plus y squared. And on the bottom you have a 2xy plus y squared. Hey, thanks for making me start with the easy one. Why am I excited about getting to minus 2y there?
It's free of x's.
Yeah, that thing's free of x's, right? So you're wondering, is this free, the first one, you're wondering, is this free of y's? Second one, you're wondering, is this free of x's? This one maybe isn't, this one is, so I'm just going to kibosh the whole calculating the other one, right? Because this is the one I want. This is my jam here. Now, what do I do with that?
Integrate it, multiply it.
Yeah, you need to multiply both sides by something to do with this.
E to the antiderivative.
Yeah, it's not actually this. You need to anti-differentiate, stick in the exponent of an e, and then multiply through by. So, my integrating factor should be e to the antiderivative of
Negative 2y.
negative 2y with respect to y.
Now, if we had only isolated x, would it be then the dx?
Yeah, so if we had gotten, you know, if in a world where hope existed, if we had gotten equals f of x here, then we would be trying an integrating factor that was like e to the antiderivative of f of x dx.
If neither of them are able to get just one variable in the end, do we just give up at that point?
Totally.
Well, number 20, that happens, but they do it.
Yeah, so there's other things you could do. The book gives you another little trick. Yeah, I would like it if you knew that such a little trick existed. I trust that you can go look it up. I'm trying to slim down on the number of little tricks you have to memorize, right? So for this, if I ask you to find an integrating factor ever, which I said I wouldn't on the first exam, right? If I ever ask you, it will be one of these two. It won't be one of the ones that you have to work harder for. And I'll remind you of this formula. Cool? Deal?
Isn't there a plus or minus on that?
Oh, in front of this?
You have to choose this one.
Yeah.
Yeah, probably.
It's
But
usually positive.
it really doesn't matter. 'Cause
Yeah, it really doesn't matter. You're going to multiply the whole
Yeah.
equation through by it anyway, right? It should.
You're going to end up with like 2xy e to negative e to the y squared, like all of that, e to the negative y squared, you take partials and it'll work out.
I don't know. Let's try it. Okay, so I think you're saying that I should get e to the minus y squared. And then you're like, if you multiply that through, it's probably not going to work, right?
It could.
Because it doesn't look like it's going to work, because there's like a lot of stuff. I don't know.
Doesn't that one not have a antiderivative you can take? Just
Well,
like
this
all-
doesn't have an antiderivative that I could take conveniently anyway, right? Okay, so my new equation, right, like star, is what?
The original.
The original equation times that thing, right? So I got 2xy plus, oops, not 2xy, 2xy e to the negative y squared times, no, plus y squared e to the negative y squared dx plus, go through and slap that on everything. So you got a 2xy e to the minus y squared plus x squared minus 2x squared y
X squared,
Ah.
minus square root.
e to the minus. Just do this. I'm not saying this anymore because I'm just screwing it up as I say it.
And are those in parentheses for the dx and the dy?
Oh yeah. Oh no, I'm not done. Dang it, Kenna. Don't interrupt me while I'm screwing up transcription. Okay, how about like that? So you get this whole thing and you're like, dude, this is probably a lot of effort for not a lot of production.
You assigned it to us.
I know. But you got it. I assigned it to you because it looked easier than some of the others. It was all polynomials. Figured it'd be okay. All right, so what do I need to do with this?
Integrate one of them.
You find it, well, you have to figure out if it's.
Yeah, ostensibly I should check to see if it's exact again, right? Because now it should be exact.
Yeah.
Okay. Did anybody do this?
Should we?
No.
We should just see.
We're so lost. Okay, so let's check to see if it's exact now, right? So to check to see if it's exact now, what do I do with the left thing?
Partial y.
Take the partial with respect to y. So partial with respect to y of, why am I writing all this crap down again? I don't know why I'm doing this. Okay, partial with respect to y should be, no, it's not that bad.
-4.
Okay, so there's a 2xy, right, times a e to the y squared. So that should be derivative of the first thing times the second, plus, minus. The derivative of the second should be a minus 2y e to the minus y squared times the first times 2xy plus 2y e to the minus y squared.
How did you get that second two there? Because 2xy was the first term.
Yeah, I had the first thing times the derivative of the second. So I had e to the minus y times the derivative of, or e to the minus y squared times the derivative of minus y squared. Okay, so here, and then what else? About negative 2y cubed times e to the minus y squared. Two of those y's came from the y squared, and the other one came out of the derivative of the inside. Okay, cool. So I just need to see that in the other derivative, right? So now I should be taking the partial with respect to x of all of this stuff. Okay. Oh, good. First one's easy. I got that one.
Yeah.
Oh, the second one's pretty chill too. Cool. Oh, hey, the third one's even chill. Y squared e to the minus y squared. And lastly, the match?
Yeah. The third term on, or second term on top.
See, so this guy is that guy, this guy is that guy. I got a,
First and the second match. Oh, no, they're not.
those two match this thing.
No, more like that thing matches the third term and the second one.
Yeah, we do 2 times 2 for 4, and y times the other y, the y squared. And
Oh.
No.
No, I
The first
know.
and right.
It's this one.
Yeah.
So this thing is minus 4xy squared e to the minus y squared, right? Okay, so that piece matches this piece. And now I'm wondering where I lost a y. Did I lose a y? Did I screw up my integrating factor? Or did I lose a y?
Well, that was the.
2xy e to the minus y squared.
Oh, you've got
Oh,
to
you're
choose
putting
the
one-
first one.
Yeah, with respect to
The derivative of 2xy with respect to y is 2x.
What, did you, is that what you started with?
Yeah, that was the first part of the first product.
I should have been doing the derivative of this. So my question is, did I screw it up? Oh, ha, it's right here. That's where that piece came from, right?
Oh, yeah.
What do I have on the left-hand side?
You don't have a Y.
No Y's. What do I have on the right-hand side? Mysterious Y that cropped up out of nowhere. Yes!
Exactly.
Okay. This matches that, so now we are exact. Okay, so my original equation, not exact. After I multiplied through by my integrating factor, this equation is now exact.
Yeah.
Oh boy, because now I've earned myself a world of hurt, right?
Well, did we actually have to do that? I thought we just had to find the integrating factor.
Yeah.
And then it said solve.
Oh,
Yeah.
Okay, so if I wanted to solve, which I think I probably should because I didn't do very many of these up here, right? So if I wanted to solve, how would I solve?
Well,
Like I found the integrating factor.
you probably want to find the potential functions of that thing.
Yeah, now you need to find a potential function for this whole business, right? Which one do you start by integrating?
How about the easy one?
Yeah, integrate the little one.
Little.
Little is a little subjective. Little's gonna really suck. Whatever, they're both gonna suck.
Well, if you're integrating with respect to x, that's a lot.
Yeah.
Yeah.
It's not gonna suck.
Okay, so that thing got x differentiated to be that thing, right?
Yeah.
Yes.
Oh, yeah, and thankfully I'm integrating with respect to x. So I've got 2xy e to the minus y squared plus y squared e to the minus y squared. And I'm supposed to be integrating px, right?
Is there an X in
There's
There is one lone x in the beginning.
Thank God.
That's this guy. So, integrating with respect to x here, you get x squared y e to the minus y squared.
And x
Plus.
squared.
X.
And x y squared e to the minus y squared.
Plus E?
Plus.
Let's see if Y is respect to X.
Yeah, so then I need some function maybe with that's constant with respect to x. So it could depend on y. So I have some function k of y. Now, you could integrate the other thing and try to play mix match, right? Which works easily sometimes. And in this case, you should
Not do that.
definitely don't do that. Differentiate the thing you got with respect to y instead. Okay, so I integrated with respect to x. Now this whole business, I'm thinking, is probably pretty close to my f. Right? So I need to take this and yeah, hit it with a partial with respect to y and maybe get closer to my function now. So if I hit this with a partial with respect to y, I get, I'll do this one. I got the last one. You guys get the rest. No? All right. So I think I got a minus 2y y squared e to the minus y squared. And then a
2y.
e to the minus y squared times 2xy. I'm going backwards for some reason.
Yeah. Yeah.
So then here I'm going to have an x squared e to the minus y squared and also a minus 2y times x squared y e to the minus y squared. And so now before I even look at this other thing, I'm going to collect some terms a little bit, I guess. So I got a minus 2y squared x squared plus x squared e to the minus y squared. plus 2xy e to the minus y squared minus 2xy cubed e to the minus y squared and a k prime of y. Okay.
Is that a e to the negative y squared on that first time?
Thank you. Oh, and I forgot to square my y on that one. Clearly this is going to go well. Okay, so what am I supposed to be matching that against?
And that.
Mu and
Yeah, the y thing in my exact equation, right? So you got a 2xy e to the y squared over there, e to the minus y squared.
Yeah.
It's like go fish, right?
Sure.
Got any x squared e to the minus y squared?
Yeah, 1.
Yeah, 1.
Yeah.
Okay. And then I got a minus 2x squared y squared e to the minus y squared. That's that first thing I screwed up. And then is the last thing a minus 2xy cubed e to the minus y squared? Cool.
So I actually used a shortcut that saved me that last annoying step.
Cool.
I noticed that all this stuff that's dy, if you were to anti-differentiate that with respect to y, you would still have an x in every term of that, right?
Cool. Yeah, so the
that
constant
clues
0.
you in that your k of y is 0.
Yeah, that's
So
awesome.
you don't have to do that whole step. You can just assume that, your stuff dx, that's going to be the potential function.
Perfect. You guys all see that? That's a cool trick. Okay, so once I got my potential function, what do I do with it?
City. That's sort of constant. Done.
So my potential function is x squared y e to the minus y squared plus
xy squared e to the minus y squared.
xy squared e to the minus y squared equals
60.
some constant.
In this answer?
And that is the answer. Cool. Nice work. That, and it only takes like half of eternity. Yeah, on a whole page. And finding arithmetic errors all over the place.
is this the only way to hit ones that have the dx and the dy appearance?
Oh no, not at all. Of course, you could divide the whole thing through by dy and take your chances that it might be linear or separable or something. Also, if you have something that looks like a mess, right, like some nonlinear thing, you could always try multiplying through by dx and writing it in terms of like in the kind of exact form and like try to see if it's exact. That would also be a rad idea and would actually work like some of the time. Cool.
I have a quick question about notation. So like in this case, when you're finding the integrating factor, and you're taking the antiderivative, and then you're kind of just ignoring the fact that there's a constant there.
Yep.
Is it kosher to write it like that?
Yeah, because
Yeah.
so
I mean, obviously you don't care, but is anybody gonna have a stick up their butt about you should like write plus C and then make a note, set C equals to 0?
yeah, I'm sure there exists a human being that would come.
I don't think the integrating factor has a constant.
The integrating factor does have a constant. If you put a constant here,
But it's not gonna affect your solution.
no, not at all, because if you put a constant here, right, you use that exponent rule to say that's a constant here,
Yeah.
right?
And you just divide the whole thing by
And then you
plus.
divide the whole thing through by the constant, and you get this, and who cares? Right? So, yes, I'm sure there's a human being who would complain.
But
that-
like most mathematicians are not gonna,
No.
complain if you
Not at
use
all.
that kind of shorthand.
Yeah, no, not at all.
Cool.
Most mathematicians would believe that the kind of person who would complain shouldn't be invited to parties.
Right on.
I was wondering there, your last step where you found all the way up to plus k prime y, and you kind of matched up at the bottom. I'm assuming if you mashed up at the bottom, there would be like an extra piece there that you just plug into KY.
Yeah, so it's certainly possible, right, that, and I forgot to cross off my last matching term. It's certainly possible that there would be something extra left dangling here. Like, for instance, if this guy had had a like plus y squared on the end of it, right?
And that'd be like K prime, right?
Then you'd say, okay, so k prime is y squared, which means that k is y cubed over 3, and so then here we would put a plus y cubed over 3, which would follow us over here into some other little bit of y's. But yeah, you play this matching game, and if there's anything left over, it's usually accounted for by the constant. If it's not accounted for by, like, if it had an x in it, right? Then it's not some function that was constant with respect to x, and so you have somehow screwed up. Like, probably that's an arithmetic or calculus error, but somehow something went wrong. Go hunt for your error. Or it's also possible that this assumption was flawed. Right? Like, if you dorked up your integrating factor and multiplied through by the wrong thing, then what are you going to get? Well, you're not going to get something that's exact, because if you multiply through by something at random, it's not going to make this equation exact. And so you'll get stuff that doesn't work because you won't be able to find it. Is that kind of